We are on our last derivative rule, and I know it feels kind of bad having 13 rules in total, but I promise there are so many more. Even if you were in regular Calc 1 at Coastal, we do, I think, like 12 extra rules in there for the derivative, so just be thankful we're stopping here. This is what we need in order to get onto our applications that actually apply to your major. So, our last rule, I kind of saved the best for last because out of all of our longer rules, this is the shortest one. So the chain rule. One thing we want to note is chain is always multiplication. So product has a plus, quotient has a minus, chain always has some multiplication in it. And what we're looking for in order to have to use the chain rule is a function to a power. Y equals f of x all raised to an n. So something that is a chain rule would be like y equals x plus 1 to the third. Whereas something that is not a chain rule would just be like x to the third. As long as you have more than an x raised to a power, you have to use this chain rule. Another example is if it's the square root of x plus 1, we're going to use the chain rule, whereas the square root of just an x, we don't have to use it. So remember that fraction powers can look like this. And another thing for the homework, this is a good hint, this is the question I get the most homework questions on in these harder derivatives homework. Something like 5 over x plus 1 to the fourth is a chain rule, whereas something like 5 over just a regular x to the fourth is not. So this one in the homework, just make sure you don't have to use the quotient rule on it, right? Because this one, we already did one like this. In our basic derivatives, we just would bring it up 5x to the negative 4, and life is good. You just bring it down. The derivative is going to be negative 20x to the negative 5. On the homework, it kind of looks tempting to use the quotient rule on this because you have x's in the bottom, but if you don't have x's in the top and the bottom, just go ahead and use the chain rule. So be super on the lookout for this on the homework. I think it's number 4 or 7. I don't really remember. But this is on the homework for sure, and I know some of you will email me about it, and that's totally fine, but you do not have to use the quotient rule. This is just a chain rule. We would say we have 5, and then it's x plus 1, that whole thing raised to a negative 4. Anytime you have more than x raised to a power, whether it looks like it's under a root, this is really x plus 1 to the 1/2, so I'd use the chain rule on that, x plus 1 to the third, chain rule on that. Anything besides just a regular x raised to a power is a chain rule, even if it's written and it looks like a quotient rule. If you don't have x's in the top and the bottom, you can use the chain rule, which is a lot shorter. Let's get into what that rule actually says. So the derivative of a function to a power, whether it has a constant multiple out front or not, we're going to first bring down our power, and then we'll subtract 1 for the new power. Just like we have been doing, we've been bringing down the power, just like this, we'd bring down the negative 4, and there it is x to negative 5. But on the inside, we're going to keep the original on the inside, and then at the end, we're going to multiply by the derivative of the inside. So chain always has multiplication. So how I'd say this rule is bring down the power, keep the original inside, raise it to a new power by subtracting 1, and then multiply by the derivative of the inside. Our shortest of our long rules. Let's use this one. We have 3x plus pi all raised to the fourth. If this was just 3x to the fourth, we'd be fine, but if there's more than just an x raised to a power, we have to use the chain rule. It's not too bad though. We're going to call it f prime of x. We'll bring down our power 4. I usually like to put parentheses or else people forget to write the new power. So I'm just going to bring down the 4 and I'm going to subtract 1 before I write the original in there. So 4 minus 1 is 3. And then I go back and I put the original on the inside, 3x plus pi. And then at the end, I'm going to multiply by the derivative of the inside. So I just use parentheses to denote that multiplication. So I'm going to multiply by the derivative of the inside. What's the derivative of 3x? That's our mini rule. It's 3. What's the derivative of pi? That's just a weird looking constant. Its derivative is 0. Okay. Bring down our power, raise it to a new power by subtracting 1, put the original on the inside, put the derivative multiplied on the outside. Looking at our next one, we have the third root of x squared minus 7x. It kind of looks like this case over here where it's more than just an x under a square root, which means it's more than an x raised to a power, right? Because we can rewrite this as the power that it is. It's x squared minus 7x, and it's the power on the whole thing is just a 1 because I don't see in parentheses that this is raised to like a 5 or something like that. If there's no power written for the whole thing, it's just a 1, and then the root is 3. So we have x squared minus 7x to the 1/3. And now I have not taken the derivative. I did the algebra part. That's the hard part because sometimes it means negative, sometimes it means a fraction. But the derivative remains the same. Always bring down your power. We're going to hold the place here and remember to subtract 1 for the new power. So we're subtracting fractions. I know sometimes this is a struggle, so I'm going to do it off to the side still. I have 1/3, and I need to subtract 1, which is subtracting 3/3. Keep the bottom. 1 minus 3 is negative 2/3. There's my new power. Okay, bring down the power, subtract 1 for the new power, put the original on the inside, and then multiply by the derivative. It kind of feels like we haven't done too much work until the end where we think about the derivative of the inside. Derivative of x squared is 2x, and derivative of negative 7x is negative 7. Bring down your power, keep the original, raise it to a new power, multiply by the derivative of the inside. Product is plus, quotient is minus, chain is multiplication. This next one is the same rule. It's a little bit more obvious. I like it better written as a power than having to do that algebra at the beginning. But either way, it's a chain rule because it's more than just x raised to a power. That's how you recognize it. And again, rule 6 is snuck in here. It comes up a lot in real life problems, and that's why I have it a lot in the notes packet. So you're not surprised when we get to the word problems. So we have e to the x to the 5th minus 2. But that's the derivative of the inside, so I'm not even going to get freaked out by that. I'm going to go for partial credit. I'm going to do the part I know. I'm going to bring down the 18, and I'm going to raise the original inside to a 17. Here I am getting lots of partial credit for at least knowing the pattern, whether I remember Rule 6 or not. Bring down the 18, raise the original inside to a new power 17. Now I need to multiply by the derivative of the inside. Now I have to think about Rule 6. So don't get too intimidated by any of these until you're done bringing down and subtracting 1 because there's half the battle. Now, what's the derivative of the power? X to the 5th minus 2 is 5x to the 4th. Derivative of the power times e to the original power is our Rule 6. Derivative of the power times e to the original power. And then what's the derivative of 9x? It's 9. Our mini rule. We brought down the power, kept the original, raised it to a new power, multiplied by the derivative of the inside. We are done with that chain rule. And that's really as hard as it can get because that's combining some of our harder basic derivative rules. See if you can try the next 2 on your own. Maybe pause the video, and if you can do these 2, then you can do any of the chain rules in the homework. We're going to call it h prime of x. I'm going to bring down the 100, keep some space for the original inside. 100 minus 1 is going to be 99. Now I'm going to go and carefully copy the original, ln of x minus 3x plus 1. Last step, multiply by the derivative of the inside. Derivative of the natural log of x is 1 over x. Derivative of negative 3x is negative 3, and derivative of 1 is 0. Bring down the power, original inside, new power, multiply by the derivative of the inside. That looks good to go. This last one is one of the harder chain rules just because of algebra. We have to rewrite it to figure out what power it's raised to. So I have x to the 5th plus 4 to the x minus 3. And it's under a square root, which means it's raised to the 1/2. The power on the whole thing that's not written is 1, and the root when it's not written is 2. So it's to the 1/2. We're going to call the derivative y prime. I'm going to bring down the power, I have to leave space for the original inside, and I have to raise it to a new power. So I'm going to do some side work. What is 1/2 minus 1? 1/2 minus 2 halves. 1 minus 2 is going to be negative 1/2. So bring down the power, keep the original inside, raise it to that new power. So let me go back and put that original inside in. X to the 5th plus 4 to the x minus 3. And then last step, multiply by the derivative of the inside. 5x to the 4th is the derivative of x to the 5th. What's the derivative of 4 to the x? It is ln of 4 times 4 to the x. That's our rule 7. And then the derivative of negative 3, it's a constant. So it has a derivative of 0. So I used to not teach it in this order, but I found that a lot of people were forgetting their new power. That's why I do it right off the bat. If you just want to work left to right, that's totally fine. Just don't forget to do your new power. I like to do it right off the bat just so that we don't forget that step. The next page is mixed review. Feel free to try that whole page before even opening the video. It'll give you a good sense of where you're at with your derivative rules.